mostly, more or less. And it's been around almost as long as the internet itself for that reason. It was defined in 1985, and basically it hasn't changed. The DNS today is pretty much the same as the DNS of 1985. I don't know if that's actually true, but I kind of assume it's true. We're here to talk about security. There have been some major security changes along the lines, along the way in DNS, but not actually encryption. And the first big proposal that I know of to encrypt DNS was DNS Curve. DNS Curve proposed a radical change to the way that the DNS system is laid out. It proposed encryption that requires participation of many different parties along the path, all the way to the authoritative resolver. And that makes it really, really challenging to deploy, and I don't know to what extent it was ever really deployed. But it did seem to inspire something else called DNS Crypt, and which was sort of a reduced scope approach that just focused on sort of the first step between the client and the recursive resolver, which is the DNS server that your computer talks to directly. So DNS Crypt was deployed in 2011 on OpenDNS, a giant public DNS resolver. And that was really the first time that people had tried to encrypt DNS, which provides these important security properties. Especially, it provides privacy. It protects DNS from inspection by anybody along the path. It was documented, DNS Crypt, but not in any formal standards body sort of way. And in 2014, there was another proposal at the IETF, maybe inspired by DNS Crypt, I guess I don't really know, to try to do encryption, but not quite in the same way, to do it using TLS, using the standard cryptography that has been developed and improved for the web. So that was 2014, and after about 2 years, that was formally standardized. I have the IETF stamp of approval as RFC 7858. And then last summer, we got the first code for client support in Android, and then this fall, we actually got the first server support from Quad9 DNS. So that's more or less the timeline of events as I see it. And what I'm here to talk about, I guess, is this sort of bit here, what I was doing last summer. So why encrypt DNS? There's a few different reasons you might want to encrypt DNS. There's a big privacy benefit. DNS normally leaks all of the host names in clear text. So if you're going to a website, and it says HTTPS in the front, you might say, this is great, I'm secure, nobody can see what I'm up to on this website. And that's true except for the name of the website itself. The name of the website is still sent over the wire in clear text, as is the name of any other domains that it loads in the process of loading, and many websites now load hundreds of other domains in the process of loading them, which can add up to a very distinctive signature that essentially reveals a lot about what you're up to, might even reveal the specific page that you're visiting. And that defeats a lot of the benefits of HTTPS. Certainly not all of them, but it defeats some of the benefits of HTTPS, and it enables some stuff that we don't necessarily want to allow. So that's where DNS-over-TLS comes in. It also enables stronger claims about authenticity. Not as strong as DNSSEC, but it does allow you to prevent tampering with DNS queries between you and the recursive resolver. And that is a serious concern for some users. There are networks that really do tamper with your DNS responses between you and the recursive resolver. And it enables all sorts of bad stuff, like sending you to an attacker-controlled website that looks exactly like the one you're trying to reach, or all sorts of bad stuff. So we built a DNS-over-TLS client for Android. We're not the first people to write a DNS-over-TLS client, certainly. Stubby is currently the most popular DNS-over-TLS client, but we hope to overtake them. if we want to actually deploy this, then we need to figure out a way to explain this to the user in a way that gives them the right impression, that gives them reasonable choices. And that's not so easy. DNS-over-TLS has significant privacy benefits, but it's not an absolute privacy guarantee. We can't tell users, go into private mode or something. First of all, we can't even tell them that this is going to prevent other people from learning the host name that they're visiting. It turns out that that actually still is revealed in other parts of the protocol. Now, I personally would like to figure out a way to reduce that leakage too. And we have to start somewhere, so we're starting here. The recursive to authoritative leg is still unencrypted. We just had a great talk in the DNS privacy group about how much user data is still revealed in those connections. It seems to be sometimes significant. There are length and timing side channels, and we have some proposals for how to mitigate that. But essentially, even if you encrypt the query, it doesn't change the length, and so I can still see how long a name you're requesting. And that doesn't sound like a lot of information to reveal to an adversary. If you do that 100 times for one web page, that could add up to a significant amount of information revealed that could, again, reveal what you're up to. And then everything related to web security is, of course, basically unchanged. We're not, the web itself sort of doesn't notice that we've done this. And so all the attacks that I'm sure Usable Security Group thinks a lot about on the web, we're not fixing any of that. Also, what is a TLS? Like, users don't even have the terminology. They don't know what DNS is, and they don't know what TLS is. So trying to explain that we're doing DNS over TLS is quite a challenge. Even if they do understand, there's a real question of identity. TLS ensures you're connected to a particular party, but who is that party, and how is the user supposed to figure that out? The usage profiles for RFC 7858 literally suggest that users, in order to ensure they're talking to the right party, should copy a 160-bit string and in base 64, and like that's the identifier that tells you who you're talking to. That I think doesn't qualify as usable security. So this is what we did, and I'm not by no means saying this is perfect. In fact, if you have ideas about how we can make this better, I'm really interested to hear different perspectives. So this is what we have now. Everything I'm showing you is screenshots from the Android open source project. So this is all, you don't have to take my word for it. Everything I'm saying here is verifiable by you if you really care to build your own copy of AOSP from master. So we have this dialog. It says private DNS mode. That was our best terminology we've come up with so far. It might change. All of this, in fact, I think is likely to change. We have a developer option, which is pretty buried currently. I suspect the final UI will be different, but AOSP at least includes that much. And it applies to all networks, but except for the special networks that don't actually represent internet connections, that like things that connect peer-to-peer, things like that. The most important thing about all this is that the default is opportunistic. And that, I think, is crucial and tremendously powerful, because it means that if we assume that most users never see this dialog, never look at it, never change it, they might still end up with encrypted DNS. Because if they happen to be on a network with a server that supports it, the client will discover that because it will probe every DNS server to see if it's accessible on port 853. If that probe succeeds, we'll just automatically upgrade users to DNS over TLS. And this is all totally invisible. There's no indication in the user interface. There's no language around it. It just happens. If users really, really care, though, they can find this dialog and go into strict mode. And that allows them to actually choose who they're talking to. So they can drop in a domain name. And that actually creates this funny bootstrapping problem. How do you connect to a domain name of a DNS server? So we have to bootstrap through the network-provided DNS server. So we take this name that you typed in, and we query basically your local networks to whatever default DNS servers. We get an IP address, or really a set of IP addresses for this name, and then we try to reconfigure. And then we connect, validate that the connection succeeded, validate that the connection is correct, secure with TLS for the right name, with a chain up to one of the standard certificate authorities. And only if all of that works, at that point, do we allow apps to start using the network. So if you're in strict mode and any part of this configuration fails, you'll be you've probably seen this if you're an Android user, you'll be in the mode where there's a little X over the network that says this network doesn't have internet connectivity. So if you opt into strict mode, then sometimes things are going to break because you said you wanted strict mode. So here's we were hoping to do a demo, but I think the technology for presentation is complicated enough as is, so we're not going to make it more confusing. But this is roughly the behavior you should expect. So if you're in opportunistic mode and you go to myresolver.net, you'll see whatever the IP address of your current network's resolver is. You'll see the default resolver IP address. So sorry, myresolver.net is doing a very tricky thing where it sends a special probe query and then uses that to see the exit IP address of your recursive. Doesn't matter. The point is it shows you what your recursive is. So this is the default address, but then if you go and switch into strict mode, that allows you to choose a specific resolver. Then you will see, I'm sorry, I highlighted the wrong thing. You'll see the ASN go to AS42, Packet Clearinghouse, who operates Quad 9. So, okay, there are probably very few people, I realize, who actually care about this, so I'll just say that this is all implemented as a libresolve queue hook, which is a cool thing that lets you tunnel queries over stuff, like TLS. If you find yourself in the position of needing to do DNS-over-TLS with libresolve, feel free to use our code under the license, which I think is Apache 2. It's reasonably reusable. It's not a library, but it should be possible to reuse. And we want to do all the stuff that, we're trying to be fast, we're trying to be modern, trying to be secure. We're thinking about doing padding and maybe even turning on the do bit. Because, hey, we're in a legacy-free environment. So, like, why not get things started off on the right foot? Oh, the do bit is a way for clients to signal to the recursive that they are interested in DNSSEC data. I am not going to be writing a DNSSEC validating client anytime soon, but it would be nice to at least make sure that the recursives are sort of ready for it by including that bit now. And we've got a bunch of heuristics and tuning, so we'll close idle sockets after some amount of time, but otherwise we're going to reuse them. We might have some kinds of limits.
So yeah. Ben, this is Allison Menken. We're close to the end of time, and I thought maybe this group would be interested to know this is like Android, so it's a lot of people have it in their hands. Yeah. What is your thinking about turning it on or not turning it on, whether it becomes immediately available to all the users who just get a new Android update?
So I don't, like I said, I think the current AOSP behavior is default opportunistic. So basically when this code rolls into an Android release that reaches your phone, Android has a complex ecosystem, and I'm not really an expert on it, so I can't really tell you the whole flow there. But at least if your phone inherits that behavior from AOSP, then it'll work if you're on a network with that configuration. Certainly where there's no proposal here to change the default DNS server on phones. So it's not like you're going to, at least not from any of this code, there's no way that you're going to get an update that switches your DNS server away from whatever it currently is.
Okay, so initially people won't actually see anything because they'll have the tool, but it won't actually talk to something that speaks TLS. I mean, I think that this group might be interested in how much end users will see it change, and I think your answer is not a lot. Yeah?
Yeah, so I think it's fair to say that currently there are very few networks in the world that are handing out IP addresses for DNS servers that support DNS over TLS. And so unless you happen to be on one of those very rare networks, this code in its default state is not going to do much. It's going to probe, find that DNS over TLS is not supported, and move on.
So I had a question about the usability of the configuration dialog, because I think that's I like that you've kept it relatively simple. I'm wondering what happens if you choose strict and you put in the name there and it doesn't work. Do you get errors immediately, or do you only find out later? Like, you see what I'm asking? Like, if I put that there and then I say DNS.quad and then I fat finger it and it says 7.net, what is the behavior? What is the user experiencing? And then my second question is, what if I put an IP address in there, or if I put a colon and a port number in there? Is it going to figure out what I mean by that or not? One's
that's
normal user and one's from the
nerd side. So I don't actually, I'm not 100% sure what will happen right now. Certainly it would be nicer to fail earlier rather than later. And so that's something we should remember and see how early we can fail. That's good. In terms of IP address, I believe that right now that's going to require you to show an IP certificate for the IP address, because this is strict mode. And if you put a port number in, I think it'll fail to parse. I do not think that we have any support for specifying port numbers right now. 853 is the one and only port.
Are there a few other questions on this? Maybe while I try to get a remote speaker stuff and ask if you have any questions. But do you need to help me with this, Karen?
There's a question here.
Yeah.
So,
Sure.
Hi, I'm Jono. I'm at UCL right now. I was wondering if or how the users would get access to whatever the EULA is for the DNS server that they're now using.
Wow, that's an interesting question. I don't know too much about that. In a sense, I would say maybe this doesn't change anything from the current state of affairs, but the current state of affairs does not have a lot of EULAs involved, or does not have an easy way to display EULAs that I know of.
Yeah. Presumably you care about what they're going to do with your queries because you're specifically.
Interesting.
Thank you.
As a standard, as interesting as a standard URL on a right. So John Todd from Quad 9. You described that there's a failover condition, or it's opportunistic. Is there any warning when you go between an IP address or the same DNS server when you're encrypted and when it falls back to unencrypted? Is there any kind of user interface that happens? Because that kind of implies a security shift that the user might be unaware of, but there's a.
Yeah, so we thought about this a little bit, because there are all these different states. You can be in a state where TLS is mandatory, but you don't care which server you're speaking to. Like there's these different axes. It's TLS mandatory. Do I want to specify a specific DNS server or not? And we decided that not all permutations of that make sense to expose to the user. And so we ended up with just these 3 settings. So in opportunistic, which is the default state, there is no indication of any kind about anything. There's no promise to the user that queries are secured in any way, but hopefully they will be. If the user cares that queries are secured, then logically they should also care about who they're secured to. And so they should probably be entering a specific host name. And in that case, we only provide strict security. There's no downgrade or fallback there.
Okay, thank you.
Hi, Dave Crocker. First, I applaud the effort, and I applaud the design approaches you took towards simplicity. So I have a couple of nitpicks that are, I think, of strategic import. Let's see. You gave a nice description of the limitations to privacy, and I think that that's true in most cases of anybody doing privacy work on the internet. The reality is then that means that the word privacy has no particular meaning for the user, and so using it with the user is probably going to end up being misleading as often as it is helpful, maybe more often. I don't know what word to suggest, but I know that the words privacy and security are not technical terms anymore, if they ever were. The details underneath them are very technical. The terms are not. Similarly, the word opportunistic is very popular within the technical community. We understand what it means. Users won't.
Thank you. I agree. I don't know really good language for this. I do think, I have a feeling that that word opportunistic specifically is going to probably change, if I had to guess. Yeah, private DNS as a description of this feature is the best we've come up with so far, but it might be interesting to see if we can sort of, among the DNS privacy community, come up with a user-facing name for this stuff that we think is a little more comprehensible, especially since private DNS already means some other things to other people. But thanks. It's yeah, it's tough to describe.
We'll start thinking about EULA. Okay, so now we're going to try to have a presentation. Sarah, can you hear me?
I can now, yes.
I guess you can. And Sarah, can you speak?
Can you hear me? Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3.
Yes.
They hear, but we don't hear.
Okay.
No, we don't.
She's talking. They're hearing her.
Everybody else is hearing
on the net, but not here. Are we?
Testing, testing, 1, 2, 3.
No.
No, we don't.
No. Yeah. In a moment, we'll just play her movie, but then that'll break the other parts of the world, right? Sorry?
Talk. Try to tell her talk. Is she talking?
Sarah, speak, please.
Testing, testing, 1, 2, 3.
That's Sarah.
Yeah.
What's wrong here?
Because she's highlighting the things that she has audio to the application.
Here. Okay, tell her go. Talk.
Try to talk again now, please.
Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3.
Oh, no, we want it on headphone.
Testing, testing, 1, 2, 3.
We could do that, but she's in England. I mean, the thing that's sad here is we were working before. What was the setup before?
Can you go in that Zoom software and make sure that it's...
I already checked it out. It's right here.
So
you said it needs to be set here and here.
Yeah.
Can we
where is it?
swap her and the next one?
Yeah, okay.
This is
right, so I'll tell you what.
We wanted to see was like something.
Our panel.
Okay.
Built-in output headphones. Okay, tell her to go and talk.
Try again, Sarah.
Testing, testing, 1, 2, 3.
We hear you. Yay. Okay, Go for it. Sarah Dickinson, everybody in England, from England.
Hi, everybody. I hope you can hear me okay, and I hope you can see my slides. Do I need to get rid of that? Okay. So my name's Sarah Dickinson. Oh, sorry?
I just made the slides larger.
Okay. My name is Sarah Dickinson. I work for Synodon, and I've been involved in DNS and DNS privacy in various ways for about 4 years now. And I've been involved in working on the IETF standards and in trying to get implementations deployed. And this talk is going to focus on Stubby, DNS privacy client, which has been mentioned a few times in the workshop. Oh, if I can. There we go. This slide touches on some things that I think have already been talked about. One of the main issues is that end users are really not aware of DNS because it's not a primary service like web or email, it's an enabler, so it's something very much behind the scenes. And I think for DNS that particularly brings out a tension when you want to make changes to DNS between it should just work because if my DNS breaks, everything breaks, to I actually really want my DNS traffic to be private. So we have to be very wary in that any change in the quality of service of DNS for an end system has a wide impact. It can be perceived by the user as the whole system grinding to a halt. And as Ben alluded to, we also need to be very careful in choices and descriptions about opportunistic versus strict. So the big question is, why do we need Stubby? As was mentioned earlier, the specification for DNS-over-TLS is almost 2 years old now. But the reality is that today, no desktop operating system natively supports DNS privacy, be that DNS-over-TLS or any of the other flavors that have been around for much, much longer. Now, in the DNS community, we know that some of these operating system APIs for DNS can be really slow to evolve and really slow to pick up new DNS standards. So we need to be looking for alternatives, assuming that isn't going to happen in the short term. To my knowledge, on the mobile side, there is nothing announced related to support in iOS. And so right now in a situation where the great work that the Android folks are doing is the exception in that they're putting DNS privacy natively into the platform. So Stubby comes into this because Stubby is an application, a standalone DNS stub resolver that can be put on user end devices. It works by running as a daemon on the device. It listens on localhost and it proxies queries over TLS. Now we've gone in quite a different direction to the Android folks in that what we do is we ship Stubby with pre-configured privacy servers. Now we have a set of about 20 privacy servers that are operated by volunteers. They're not any cast like Quad 9. But they all make their authentication information available so that we can ship it with Stubby. Because Stubby is something we think users will actively choose to install, we've actually made the default strict, but it is fully configurable and can be dropped back to opportunistic. For those not DNS experts, this is a quick overview of how Stubby works on an end user system. So on an end user system, typically you have a number of apps, all wanting to do DNS lookups. They tend to funnel their DNS queries through the system DNS. And when you're at home, this is typically going to send your DNS queries to RSP. When you're in a coffee shop, it could be anywhere. And some people actually choose to actively override it and send it to Quad 8 or 9 or wherever. But in all those cases, the system DNS is sending queries out clear text. There's also a few cases where apps choose to implement their own DNS lookups. That can be good if they're doing it encrypted or sensitively. It can be bad if they're bypassing the system DNS. So Stubby fits into this by running the local machine. The user configures the system DNS to point to Stubby. Stubby uses a pre-considered set of servers to send queries out over TLS to the privacy service it has. One thing to point out is this Stubby does not intercept queries directly from apps, so that is still an outstanding problem. Where are we with Stubby? We've concentrated today on the command line. We still describe it as being technical advances. However, it's very rich in the variety of features that Ben was alluding to earlier to make it performant and as privacy preserving as possible. So we do padding, we do DNSSEC, and you can actually do TLS 1.3 with Stubby if you want to. We're now at the stage where we wrap this in a GUI and an app. Get it. Okay. I'm hearing that my audio isn't great. I shall carry on unless I hear otherwise. So we're now starting to wrap Stubby in a GUI. We have a prototype GUI for macOS, which is what I'll show you in a moment. It really is in the early stages of development. It is little a bare around the command line tool. Okay, and we did also start work on an iOS app. Unfortunately, that is a roadblock to do with an internal in iOS and the way DNS is handled. We're really hoping to get that unstuck.
Should I play the video here? Yeah. You
I didn't mute myself on purpose. Is that better?
Yeah.
That's better, yeah.
Okay. Do I need to go? How far do I need to go back?
The demo.
Okay. So let's just run this again. So I'm opening Stubby in this case just as an icon from my dock, and that's the main panel that the user sees. I'm also going to open up a log window just so you can get an idea of what's going on behind the scenes. So for Stubby, we've got a test mode where the user first starts Stubby as a service, and then they can just hit a test button so they can see what's going on. And the reason we did this is because the default for Stubby is strict mode. We're assuming most users consciously want to install Stubby to get privacy and want to use strict mode, although they can fall back to opportunistic. But what we can see here is that test mode has opened up a connection to a test server, and the connection is in strict mode, and we've got a response back. And this tells us two things. It tells us 853 blocked on this end device, and it tells us that the round trip time is reasonable enough that we didn't get timeout. So once the user knows this basic is working, they go ahead and actually make a change to the system settings by checking the box and hitting apply. And as soon as the user does that, you see activity in the log. And so what you see is, in this case, it's being configured with 3 upstream servers with 3 different IP addresses. And you can see DNS queries going to those upstreams, and you can see we're getting responses and we're not getting timeouts, and we're authenticating servers, so that means everything is good. And this is all the DNS activity that's just happening in the background on a machine. Now, for most users, if they're willing to trust the default config we ship with Stubby, they're done. They can close this down and it will just work in the background. And so that's all there is to it for that case. If users care, they can go in and change the configuration. At the moment, we only have the text file, which has the myriad of configuration options. Clearly, this will be hidden and turned into something else. But as Ben was alluding to earlier, I just wanted to mention, at the moment, the minimal configuration for Quad 9 is an IP address and a name. The next big release of Stubby, you'll be able to do this just with a name in the same sort of fashion that Android are moving towards. So that's the configuration. And if users want to turn Stubby off, it's just a single click on the stop button and it reverts the system to exactly how it was. So what user feedback have we had? We've had lots of feedback on the command line tool. Surprisingly, we had a ton of feedback from Windows users. We worked through a bunch of teething problems, improving stability and logging. We did get some reports of 853 being blocked from maybe like 10% of users. It's a bit hard to quantify. We found that in all but one of those cases, all they had to do was switch to port 443 and everything started working. What we haven't had is lots of people saying, oh, I tried Stubby and I turned it on and my system grounds were halt and I turned it off. So what we're not getting is people complaining about the performance. I think 999 has hugely helped because it means most people have a local server on their Anycast network, but I'm glad to say it isn't a thing that's coming up in feedback. The people are using the GUI seem fairly happy, and the biggest request we had is, when are you going to port it to Windows? Quick Stubby to-do list. Clearly, we need to simplify the main panel and make it look a lot more like the Android one. In my mind, I can imagine the log window becoming something a little bit like the connection doctor window from the macOS Mail app, if you know it, where you, it's this window shown at the bottom, where you just have an entry against a server, a traffic light to tell you whether it's working, and you can double click and drill down into it. And in fact, I can also imagine if we ship pre-configured servers, there being a checkbox here where you just turn servers on and off as you want to use them. So I'm leaning towards the hope that this wouldn't be entirely dissimilar to setting up an email account, which is something that users can be walked through and is possible. And lastly, just to touch on some things that were raised previously, in that we really need to think hard about the language we're going to use. Do we talk about DNS? Do we talk about queries? Do we talk about lookups? Is it secure, private, safe? What? Where do we go with that? For Stubby as a standalone app, we've got questions about how much we integrate it into the system settings. And on the desktop, as well as with the mobile, we really need to think about these status indicators and reporting errors to the users as well. So general usability issues. And with that, I will hand back to the chairs. Thank you very much. There we go.
How many here have ever seen me give a web security lecture created in 2016? Perfect. So one thing I say we're using which can we turn this way? Hardware. Yeah. Okay. So the first security feature in HTTP was basic authentication. The first use of cryptography to provide protections in HTTP was digest authentication. People here know what digest authentication is. Excellent. You're all old. The first cryptographic protocol to protect web content was SHTTP. SHTTP, which clearly failed only because of its name, not its complexity, tongue-in-cheek. So it took us several iterations of trying things out from a protocol cryptographic technology point of view to get to HTTPS, which, clearly because we're looking at TLS for DNS privacy is a pretty successful security protocol. It sounds to me like this community is very much early on that curve.
So I can talk a little bit about the Chrome perspective on this. I work on the Chrome usable security team, which also drives a lot of the Chrome and Google-wide TLS adoption efforts on the web. As I was listening to these talks, definitely a lot of parallels stuck out to me. The last 5-7 years has been so pivotal in HTTPS adoption. And I think one of the lessons from that is that positive security indicators don't work. And not only do they not work, they worse than not work, because once you kind of start to do them, you're sort of stuck with them in this terrible middle ground where they mean nothing to most users. Most users don't notice them, but if you try to take them away, there are going to be users who think something's very wrong. So concretely, what I'm talking about is the green lock icon that we associate with HTTPS, which we've been teaching users for decades, means you have a secure connection. We didn't do very well at teaching users that what that means. I think these DNS privacy issues are a testament to that. Users will assume, because when they see the green lock, they will assume that their DNS queries, for example, are private to the extent that they understand what a DNS query is. So we have this green lock that doesn't really do a great job of communicating anything to users, but at the same time, when we get to the point that we want to get rid of it, it's going to be that is going to be quite a challenge. So that's sort of the parallel that I see, that when we have these security technologies that are not widely deployed, it's tempting to stick something in front of the user to say, hey, look at this fancy new shiny security thing that you have. But once you do that, it's probably not going to be very effective, and if it is or isn't, you're going to be stuck with it forever.
Okay, I'm going to ask a question that, it's going to be for everybody, which is, how important is it for, so we remember we have multiple use cases. We have the normal people who are maybe not life and death, although they would rather that people were vacuuming up their queries. And then we have people who are life and death who may actually really be targets. And I don't think it necessarily has to be deeply distinguished. But how important is it that end users be able to know if something is working? Like in the HTTPS case, we want to know that our credit cards aren't being broadcast to bad guys who are just listening in. How important would it be to get that right for DNS as well? And we could start with the DNS folks just to give them a chance to speak, but we'll have both perspectives on this one too.
First off, I think when we use our credit cards over HTTPS, it's equally likely that they are being broadcast to the bad guys. Because it could be that you're giving you're just going to the HTTPS to the wrong place, or you don't know what that vendor is doing. Certainly, if you use your credit card in a physical scenario, it's being broadcast to whoever picks it up. So I'm not sure that those promises are the same promises in any case. I think I'm in line with Emily here, that the more visible security indicators that we have, the more trouble we get ourselves into. And the fact that there are some people who are targeted, so I think we need to acknowledge that we are all currently targets right now, right? That the surveillance economy is sort of designed around the idea that people will collect data about you and use it to and monetize your experience in one way or another.
Let me emphasize, not necessarily visible, consistent. So if you're in it, it's consistent versus whether you know or not whether it's consistent. Okay. I think those are two different things.
Sorry. So your question is are we expecting to, should the user be able to have a consistent visibility there? Yeah. So
consistent secure service rather than maybe it's there, sometimes maybe it's not there.
Right. I tend to look at consistent secure service the other way around, right? Which says that when a service is no longer secure, it becomes inoperable, right? And so what we're really saying is how many additional failure cases are we willing to put the users into, right? And I think that there are users for whom they would rather have a failure than have an insecure service. But I think we need to be really clear that that is the difference, not the difference between, oh, well, I'm looking at this and for the moment the lock is green, therefore I'm okay, and then when it turns a different color, then all of decide to be green. And I think that trade-off, and that's the simple trade-off I think that Ben is talking about going to strict for the Android implementation, is one that I think a user can understand, and it's a harsh trade-off, but that's the trade-off we're asking them to make.
I'm definitely wouldn't hold myself up as anyone having any kind of expertise in usability. I do think that there's if you sort of take the cryptographer's approach and say either it's known to be secure or it's broken, then it's at least a safe start.
So I found your emphasis on the notion of something consistent to be extremely intriguing. One of the papers that we had at USIC, a previous session, was about patching. And as we all know, patching is now a constant in our lives. And patching is a constant in our lives because software errors are a constant in our life. And so I think we have a software using culture that is very much used to bugs coming and going fairly constantly. I will just point out that a paradigmatic study in the usable security community, the Emperor's New Security Indicators, this was quite a while ago. One of the cases they tested with was removing a passive security indicator site authentication from a banking site. And what they replaced it with was our award-winning site authenticator technology is down for maintenance. You can come back later when you'll see it, or you can continue. Whatever you feel is safer. And unsurprisingly, in the study, users just kept on going because even then, users were used to inconsistency.
On the other hand, we had a similar situation a few years back with Chrome's certificate warnings when a certificate fails to validate, where users were given the choice, do you want to ignore this certificate error or do you want to continue? And as of a few years ago, something like 70% of the time, users would choose to continue. But with some tweaks to the UI and how the message was presented, that click-through rate has now dropped to about 30%, which is still kind of high, but actually not that high when you consider the huge numbers of certificate errors that are just completely false positives, things that are not actual attacks at all, where really actually any of us as security experts might reasonably advise the user that what they want to do is trigger warning in that case. So I don't think it's hopeless that a user, given a choice to, continue or not in the presence of a security failure, I don't think it's hopeless to get them to do the right thing, but it's really challenging.
I would actually just add, I mean, Google has been to me a leader in the area of getting warnings that make sense, and I think the statistics I've seen are better for the warnings where the authority speaking, in this case Google and Chrome, knows that there is a problem, aka malware sites, than there are when the authority speaking says there's something wrong with a certificate. It might or might not be wrong. And I think those are two very different cases.
Okay, so in the first I wanted to say to the audience, much of the progress that was made was actually made by doing real good, rigorous usability studies. And so we in the DNS community would love to promote collaboration so that we can do those things as well. And finally, I wanted to see if anyone wanted to ask one or two questions to the panel. And you'll have to come and get this or take their mic. And then we should end in not 2 minutes. So you have a question.
I'll speak really, really loud.
But that won't work for the
No, it won't work for the
I'll
remote
use
session.
my phone.
So tell us who you are and tell us what your question is.
James Paul at BYU. So we've done several studies now interviewing users about encryption. And a piece of that interview is always to ask them about security indicators, log by time. And nearly universally, they always confuse it with site security. They think that the browser is telling them that this site I'm going to is safe or secure. If I log into them, then my password is safe with them. They're good guys or a good site that I can go to. They do not understand connection security. They're thinking that site must be encrypting my data at rest. It must be taking care of me. Security is something that they're doing for me. So for the DNS folks, the worry that I have is that as you talk about DNS privacy, you're going to get confused with the sites that I'm visiting are keeping my private information safe and not sharing them, which is exactly not likely what they're doing. And so I'm wondering how you avoid conflating the user's minds, site versus transitory security or privacy.
Sure. So I do think this is a concern. So let me say, first of all, I by no means want to imply that we have perfect or even very tuned user interface here. I think we could really use some input from experts or researchers who are interested in trying to figure out what happens when users do this kind of stuff. The interface that I showed you is, maybe I didn't show you exactly how deeply buried it is. It is almost impossible to find in the version that I showed you. So in a sense, I'm not worried about it. Anybody who makes it to that stage has already gone through a deeply arcane process to prove that they are a very sophisticated user. But as such, that means that any potential benefit there is very deeply buried as well. And I hope that we can actually get to a much less hidden configuration panel that will have more of these issues. But it will still be, at least for the foreseeable future, that system is going to be some sort of settings menu. So I think any time that you're inside the settings menu, most users are not going to find it a certain amount of presumption of sophistication, but probably not too much.
Okay, so I just wanted to remark on the optimistic nature of the default setting that Ben proposed, where there is no feedback to the user whatsoever. So we don't run into the problem of not meeting user expectations simply because the user has no expectations whatsoever. And I think that's actually a really convenient place to work from. And I think it also, in some sense, addresses a little bit of Allison's point earlier about, most people who might use this are probably not in a life or death situation. We're not talking about something that's going to make the difference between somebody getting locked up in jail for a long time, and we're not telling people that we're going to keep them out of jail, right? And in fact, what we're really trying to do is, I think, with the opportunistic modes, just increase the baseline defense against passive network collection of this data. And I don't think that we're making any claims to the users that all of their name lookups are going to be safe, right? In particular, Ben lists like 4 other ways that information leaks, and we haven't solved those. So I thought, I don't know your name, sorry, but your comment earlier about are we going to show the EULA of the provider? I think that's a really interesting idea. This question of like, okay, if the user does go ahead and opt into this, how can we help them to understand what they're opting into? What is this relationship that they're establishing? And earlier today, I had a talk about what is this trust relationship. And I would love to hear people's ideas about how do we have that, so that for those users who do make an explicit choice and say, I want to opt in, how do we make sure that they're making that, not conflating these other efforts?
I'll just add a quick cautionary tale about life and death scenarios. Is anyone here familiar with public key pinning? This is a kind of an advanced security thing that websites can opt into, which is now being deprecated. But the cautionary tale is that there was recently a post on a public mailing list about someone who led some activist organization who was saying, we have been relying on public key pinning for our supporters who are in life and death scenarios. And now public key pinning is going away, so what do we do? And that was a very interesting moment because in that threat model, public key pinning did not do what this person thought it did. And even though it wasn't user-facing, even though it was a very technical feature that was being assessed by a technical person, that information was being passed along to non-technical people inaccurately, and they have been putting their lives on the line based on basically a false premise about what public key pinning does for them. So sorry to be such a downer.
Actually, that's a great purpose. Thank you.
I'm happy to answer the question.
I don't know. I think we may need to give back the usable security people their time. So we probably should exit rather than taking up more of your session time. So you only scheduled until now. But if you'd like to take a little more time, we could do that.
They scheduled till 3.
Oh, I scheduled till 3.
They scheduled till 3.
Really? Oh, not an hour. Okay, all right. Let's ask some more questions then. Okay.
You have Nick Feenstra at 2:30 for us.
No, we don't, it turns out. But I thought we had understood we had an hour. So we had some communication. We're good communicators as well.
I have a question that I to raise for the usability folks here. So one of the questions that I like to ask people who are implementing the DNS privacy stuff is not just how is the user going to opt into it in the same way, but what happens when it fails, right? And so I asked Ben that earlier for the Android thing, but these are situations because users move between networks where you can make a decision that says I'm going to use this kind of strict DNS privacy in one network and it works, and then you move to the next network and it works, and then you move to the next network and now it doesn't work, right? And so what kind of usability approach should we be looking at? So like with Stubby, I didn't get a chance to ask this to Sarah. I don't know if you're still on. But like, if someone configures Stubby on their Mac and then they click, yep, it worked, I'm going to stick to it, and then they remove their Mac to some new network, what kind of feedback can you give the user at that point when they've already hidden away the decision that used to work for them and now doesn't? And I don't know what the right answer is there. Nobody else is here.
I actually had a follow-up. I heard you say, because the user chose strict mode, right, then there will be failures that happen because the user chose strict mode, right? And the question in my mind was, will the dialogue indicate the failure happened because they chose strict mode? And so I think there's at least two parts of that problem. right? Maybe 3 parts, right? Like whether or not you indicate there's a problem, whether or not you indicate what the reason for the problem was, and whether or not you indicate to the user what the right thing to do about that problem is. And I feel like the usable security background on error warning literature that's gone through many, many, many iterations has parsed through all 3 of those aspects to various levels of success.
So if I could try and speak to that briefly.
I think Sarah's trying to talk. I think Sarah's trying to answer.
Okay, can I try and, if you can hear me, I can try and answer that.
We can't replace her.
So one thing we've found with Stubby is that diagnosing what exactly is yeah, hey, testing 1, 2, 3. Can you hear me?
Yes.
Okay, I can't hear you, but I'll go ahead and talk. Okay. One thing we've run across with Stubby is actually diagnosing what the problem is and therefore recommending a solution is pretty non-trivial because there are so many things that could go wrong. And pretty much the only thing that we've thought about doing is just saying fall back to opportunistic, because then at least you will be in no worse a situation than you probably were to begin with. If what we do in opportunistic is include the set of default DNS servers you would have used anyway. So with strict mode, if it goes wrong, it means it's gone wrong for every one of your configured servers, which likely means it's a global problem. Something is blocked somewhere if you really can't get to anything. So I think I'll stop speaking there if the audio is against me.
Go ahead.
Okay, we have a new question.
Yeah, so this was a question just in the answer.
I have turned it down. Yeah, I turned it down on this one. Keep muted. Go ahead.
So this is an answer to the question from a few minutes ago about what happens with DNS. So we did some interesting research where there's a tour to a censored environment, and caveat there is it was censored entirely artificially, so in the US, so they can actually face threats to their Wi-Fi based on the censorship. But we recreated this censored environment, and we saw what happened when people tried to connect to default settings in this environment. And basically, one of 2 things happen most often. People give up. In fact, people give up a lot using tools even when they aren't censored, and that's something another research has shown. And the other thing that happens is people try to go through the settings and play with them until it starts working. And one thing that made me think of that is this field you had where you had to specify the name of the DNS resolver. So in Tor, one of the features you couldn't do, you can't specify is you can use a proxy. So if you're in a local corporate network and you need a proxy to go to the internet, and you can specify that before you even start using Tor. And as people were trying to get Tor to work, and they were getting more and more desperate because it wasn't working, it was censored, they're trying to use a proxy, even though in this case it wouldn't be possible. Censorship is not on the local network. They went to this proxy screen, and they were putting in various values that
challenging because users don't understand DNS in the first place, let alone that's why actually my biggest belief is I'm going off on a tangent already. My biggest belief that LastPass is a real help for people is not because it helps them remember good passwords, but because it doesn't give them the password option when they go to the online domain. Right? If they type Facebook with Facebook with 2 Ks, it won't take them to the phishing domain where they get their password. But anyway, going back to what I was starting to say. So recently we wrote a RFC called DNSSEC Roadblock. And the whole purpose of that RFC was really to document all the different ways that it could go wrong when you're trying to use DNSSEC. It gives you a list of test conditions, right? So what we do test-driven development for code all the time. We don't do networking or test-driven networking all the time. I think for things like Stubby or other things else, the pendulum has swung way too far away from 1980s and 90s when you're using a computer and give you an error code that would very accurately describe the exact problem you were having. It'd be 142.5 or whatever, and you have to go look it up in a book. But nowadays, all we get is can't communicate anymore. And we do that for user simplicity because users are being overwhelmed in browsers and overwhelmed in a lot of other places that they couldn't understand the error code. But that doesn't help the administrators that are trying to help them. And so somewhere we need to find sort of the right middle ground. And I'm going to argue that error is not, we're getting close to the single word error, popping back up, and that's no longer really sufficient. But if when people are detecting network management, configuration changes or other config changes, or maybe just once an hour, go out and try all the little things that you need for DNS security or any service to succeed, then you can report something. And you can say, you know what, your networking environment just changed. You went from mobile to Wi-Fi or whatever, and things are no longer working. Watch out.
No, sure.
Myself.
Hi, Dave Crocker. So I'm inclined to completely disagree with Wes. Mostly to be cantankerous, but that there is continuing to be a tendency to want to have users be knowledgeable. And let me suggest that's the biggest usability error we can make. Now, the best I can think of to navigate this with respect to what Wes just said is, in fact, including the error code that has no meaning to the user, so that the user can report that, might make the most sense, because there's no way the user is going to think they're supposed to understand it, but at least they can report it. More generally, the distinction I'm finding in this piece of work, but going back also to HTTPS and opportunistic encryption, is the difference between doing better and doing well. And if you have a tightly operated and consistently performing environment, you can do well. You can reach some kind of perfection. We aren't there. We may never be there. And expecting users to navigate the noise of the doing better but not doing well is another kind of usability error. We're not going to succeed there. We're not going to get users to be able to make the right decision, to echo Emily's comment, because certificates don't work very well. That's not the user's ability to navigate. That's the fact that sites keep generating their own certs because the PKI structure is a problem. And so expecting users to make the right decision in the face of a very noisy certificate environment is an unreasonable task for typical users to be given. So let me suggest that for DNS, I'm actually going to bring this back around to the topic at hand. For DNS, whatever it should be called, privacy being the wrong word, that you don't tell users you now do better buffer overrun detection. Let's not tell users we're doing better DNS protection. Having users able to say, I will only deal with a strict environment, that's fine. Having the default be opportunistic and completely invisible to users unless they dive deep, seems like the best way to navigate this. So the best way to do the usability is don't impose any of it on the user unless the user knows what they're doing and wants to dive in deeply.
This is a question that I had, which was we've had all the years of thinking that educating users is actually not going to work. You know, why Johnny can't encrypt and all that stuff. So do we think that, do we think there's any point in starting in on this with DNS, which is, after all, one of the most low-level things? Those of us who work in DNS know how hard it is to explain it to anybody, even though everyone has experienced it. So what are your recommendations in that regard, since Dave just told us that we should assume some people will become well knowledgeable about DNS and not become part of the DNS community?
Yeah, so I think there's been a lot of people pointing out that if you give users a way to put themselves into a fragile state, then it would probably be good to figure out a way to tell them when that has come back to bite them. And that's an interesting point that I'll have to think about some more. In the question of expertise and how do we convey the right information. One thing that has come up is the question of whether we can bind this concept to some other concept to some other relationship that users already have. So if the concept of DNS is too narrow, it is sort of too small a piece of the security and privacy puzzle for users to have any specific comprehension of it, maybe there's some way to bundle together a whole bunch of these tiny pieces into some aggregate that makes some sense to users. Maybe one example of that is the way that users can use VPNs. And when users use a VPN, they are implicitly using a form of secure transport for DNS, at least if the VPN is configured correctly.
I think there's a middle ground between educating users and throwing up our hands and saying, we can't, it's hopeless. And as an example of this, I want to go back to HTTPS certificate errors, because it turns out that self-signed certificates is a problem, but it's a pretty negligible fraction of all certificate errors. And for the things that cause the most certificate errors, we actually do quite a bit to try to tell the user what's going on and how they can fix it. So a few examples are, and when I say we here, I mean in Chrome and maybe some other browsers also. So when the user's clock is wrong and they can't validate the certificate because their clock is wrong and the certificate appears to be expired, we tell them, fix your clock. You can't talk to the site right now because your clock is broken. And I think that's a good example of where, we're not trying to educate users about why they need a accurate time to set up a secure connection. We're just saying, you can't talk to the site, here's how you can fix it. Another example is captive portals, and more recently man-in-the-middle proxies, when we can detect that you are getting a certificate error because of some kind of entity on the network like this. We tell the user why. In the case of a captive portal, we prompt them to go log into the portal. The case of a man-in-the-middle proxy, like a middle box, it's a lot harder for the user themselves to fix. That's a situation where they have to go talk to their network administrator, or someone else has to get their machine back in a usable state. But we hope that by at least telling them this is the problem, this software or appliance on your network is causing the error, that's at least something for them to kind of start, a path for them to start down towards resolving the error.
I salute that kind of work. And I think it's also interesting to see how the programmatic diagnostics that we build into these tools become then new avenues for security attack, right? So like one example that I can think of is on macOS. The way that macOS deals with captive portal is that it launches maybe it doesn't anymore, but I believe at some point it used to launch a browser window, a totally undecorated browser window that was just to the captive portal page. So it's pretty trivial to make a website that looks like, say, mail.apps, the mail server forgot your password, give us your password again. And the browser window that pops up there, because you're on a captive network, doesn't, I think, even show up in the title bar. So you still see the title bar on the desktop of what application you were looking at. And then suddenly there's a attacker-controlled dialog box, right? And so I just think it's like, I definitely salute like giving users channels to get out of this stuff, but we need to be aware that as we get down the security, the usability route, we aren't actually just crafting a channel for the attacker to use because the old channel doesn't work, but now we just gave them a new one. So I just think there's an interesting double bind there.
And along the same lines of that trade-off, there is some research in the usable security community on the usability versus security trade-offs of end-to-end key management versus key directory key management. That's something we all struggle with constantly, is how much security you can get with a certain level of usability versus whether or not users are interested in the next level. And that particular paper I'm thinking of, because I just re-looked at it, users understood the trade-off in some qualitative context and were okay with it.
Okay, I think that was really illuminating. We have 6 minutes left, and we could actually find another question in the chat about, I can reiterate, we'd like to collaborate. And maybe what we should do now is use these 6 minutes to move ourselves gracefully back to our room. But I want to very much thank you for hosting us here, and Ms. and Emily Stark for joining us in our panel. So let's thank the panelists. So slight break while we exit stage left, pursued by Bear, or not.